we go, number 12. Okay. Remember, the rules on the pink sheet are very, very strict. So as you look at the pink sheet, there's only 5 choices and then the expanded version. You should notice that none of the rules look like this. They all kind of look like this, but they don't look exactly like this. If you need more help seeing why, talk to me. Suggest if you're like, oh, why doesn't this rule work? Just ask me about it and I'll tell you. Okay, so none of the rules fit. You are not allowed to split up an antiderivative by multiplication or division. So you can't do that. There's not a quick algebra trick, although that will be helpful in some cases, but not here. So what we're going to use is what is known as, here's the official word, anti-differentiation by substitution. Okay, that's way too many words, so I use what my calc teacher used. I call it a U substitution. In other classes, I've heard teachers use that term for different purposes. So you're not using U substitution for the same thing you used it for previously, just same name. Okay, I'm going to teach you steps for doing a U substitution. My method is not necessarily exactly the same as other teachers, but I feel strongly this is the best way to learn it. Once you learn the process, you can kind of forget the steps. But the first time without the steps, it can be a real struggle. So here are the steps. You're only going to use U substitution, well, there might be an exception, but 99% of the time, you use U substitution when you see what Abby saw, 2 things being multiplied. Okay? 2 things being multiplied. So when I look at this, here's what I see. I see 1 over 2x squared plus 1 being multiplied by 12x over 1. I see 2 functions being multiplied. Unless I see 2 functions being multiplied, except for an exception, which is rare, I am not using U substitution. I've got to find another way. But if 2 functions are being multiplied in this class, good chance U substitution will work. In the next class, you have more things to pick from, so you have to kind of expand your thought process. But for our class, you just look and see, is there a rule? Yes? Good. Go. Done. No rule? Look and see if you can see 2 functions being multiplied, then we're going to try U substitution. Question? Awesome. Okay, it's also helpful to get rid of multiplying constants. So I would have pulled out the 12. Questions? Okay. The 2 multiplying functions need to be of the form something to a number. Okay, this idea of saying something to a number, that's not like pure math language, but it sure helps common folk like myself to understand what the heck mathematicians are talking about. Okay? Something to a number. That's like the 2 functions you see here. One of them could be of this form, or both. This one this is x to the first. So it's something to a number. The other form you're looking for is maybe e to the something. And the good news is, what I'm listing here is right off the pink sheet. It's just like straight down the card. The first one says x to the n. Well, to use the pink sheet, funny. Reminds me of my 2.5-year-old granddaughter used to say sheep. She was bad. Okay, right on cue. Look, come on. The pink sheet. Here it has to be x to the n. It cannot be anything but x to the n. But when doing a U substitution, you have more flexibility. It just has to be anything to the n. Got to see the difference? E to the something, 1 over the something, sine or cosine of something. So what I recognize is, This is something to a number. It's x to the first. This is not something to a number. This is 1 over something. See it? Okay, it's called U substitution because what you're going to do is write down U equals something. Okay? And the choice of U is always the something. So here I've got something to the first, so I could write U equals x. I could make U equal to the something. But U equal x is a useless, funny, substitution. Not very funny, no one even smiled. Okay. U equals x is a useless substitution. Because all you're doing is rewriting this with x, U in place of x. Got it? Okay. The other thing is this lesson would drive English teachers crazy. Because you keep saying U when you mean the letter U, and it sounds like I'm talking about you. And that's also funny, I think. I got a nice sign out of that last year in this class grade, A2. Mikkel Dahl and Ellie Lysenko created from the movie The Help, where the maid tells the little girl, "You is special, you is smart, you is X, bad choice." No. Please.
So like the U, whatever that is, are we just changing out the X's for what we choose for the U rule?
Yeah. I promise you, this little method, as Parker DeYoung said last period, it's going to feel a bit like wizardry. I promise. Like we're going to do some stuff and suddenly the answer will appear and you go, what? How did that work? The good news for our class is you don't really have to know how it works. You just have to know how to do it. So if this feels like a wizard, Harry Potter, great. Okay. But look, first thing, you have to recognize two functions being multiplied. The two functions must be of the form, one of these 5. Okay? Here we have something to a number. So I could pick U to equal the something, which is x, but that never works. So I don't. My other choice is 1 over something. That might work. So I write it down. U substitution does not always work. But for our class, you're pretty safe, because if they give you a problem, I've never seen them give a problem where the answer is no solution. So it's either going to be just straight off the pink sheet, U substitution, or algebra trig. So it usually works. Next step. You take the derivative of both sides of this equation in terms of the input variable. The input variable in this case is x. So this side becomes d over dx of u. I feel like I'm in that movie. U is special. U is 2x squared plus 1. Okay. I should have had that. That would have been awesome. Little girl's like, what? Mommy, I'm 2x squared plus 1. Okay. Question? Just keep going. This side's just du dx. This side's 4x. Yes? Okay, here's where you check to see if U substitution is going to work. This derivative came from taking the derivative of our choice of U, right? Our choice of U came from the first of the two multiplying functions. The derivative of our choice must match the other of the two multiplying functions, except that a multiplying constant doesn't get in the way. It's a perfect match. I saw two functions being multiplied. From the two, I picked a U, right here. I took the derivative of U. My derivative is the other multiplying function. You can always ignore the multiplying constant. It won't get in the way because you can factor it out. Question? Please.
So if the one thing, the first matches the second, and besides the constant and stuff, if it's the same, it works.
Then you keep going. If it doesn't match, you've either done something wrong, or the use substitution just won't work. And you've got to say, no, I guess I should have just used the pink sheet somehow and I just messed up. Or there's an algebra trick which we'll practice in the future. So. Okay, now I do what the process is called. I do substitutions. Okay, there's several that we make. First thing, let's see. This is going to become 1 over u. Look, see? 1 over u. I got to get rid of the x dx. So I'm going to work over here. I multiply, remember this is just du divided by dx. So I multiply the dx across. And I move the 4. This is the moment where everyone in this class joins the freaking Genius Club. So. Had a teacher in college. He told a nasty joke. It was mean, and that's my cue to tell it. Apparently, so every time I bring this up, I'm like, I shouldn't tell this joke, but I tell it every year. Oh, okay. He says, we're learning something like this, where it's like, what the heck is going on? Man, there's symbols everywhere, and it's like this becomes this, and once you get good at it, like it's cool. Like, hey, I'm smart. Look, I can do. He said, so some friend comes, some bully comes up to you, right? And he likes to just put you down all the time, you know. He said, why do you learn this? What a waste of time. What a waste. It's like, you can't even understand that. You know, he's just picking on you, and you're like, it's like, how in the world can anyone understand that? You just turn to him and say, it's easy. You're a moron. I'm a freaking genius. So it's not that funny, but whatever. Okay. Moving on. I gotta stop telling the joke. It never gets very many laughs. So oh boy. Okay. There was one funny thing that happened one year. I told the joke. I kid you not. I told the joke, and not 5 minutes later, an administrator comes in the room, has to ask a question about something or other, looks at the board and says, I don't even know what that is, and walks back out. Whole class laughed. Okay. Moving on. I told you I shouldn't tell it. I feel bad now. Okay. I must repent. All right. Stop telling these bad jokes. Bad habits.
And it's on the recording.
True, it's on like YouTube videos year after year. Okay, look. Right here. It says x dx. Remember, equal means equal. So wherever I see x dx, I can write 1/4 u. No waiting.
Yes, wait.
No waiting.
No waiting.
Now we can wait. Please don't do what somebody did yesterday on the test. They literally wrote, it isn't exactly what they wrote, but it's the same thing. They wrote 3 equals 0 equals 7. And he's like, how did I lose a point? I'm like, look at what you wrote. It wasn't exactly that, but it really was like 2.5 equals this integral equals 4.3. Like, you think 2.5 is 4.3? He's like, no. I'm like, if you think that, please break out your wallet. I would like to make some trades. Justin, please.
How did we change the 1 over 2x squared plus 1 over 4?
We did not. Right here it says 1 over 2x squared plus 1. Right here it says u is the same thing as 2x squared plus 1. So in place of 2x squared plus 1, I can write u. So I did that. This says x times dx. This says x times dx, as Lizzie noticed, is exactly the same thing as 1/4 du.
I thought u was a 4. So
You're good. You good now?
Yeah.
Yeah. Lizzie, you good?
Good.
All right. Everybody else good? No. Talk to me.
Wait, so where did the 1/4 come from?
No worries. You're doing just fine. You're doing fine. You okay with this one?
Well, yeah.
Like if it feels magic, don't worry about that part.
No,
Just
I
make.
was wondering where the ones were this.
You're okay. Are you okay that this is x times gx? Good. So over here, so what's weird about this process is everything we do is legal because we just keep using the equal sign. It's just weird how the combinations all work. Is that okay? So are you okay with this? So I multiply the dx across to get to here. Good there? Now I'm going to multiply both sides by a 4. See that? So now x dx can be replaced with 1/4 du.
Oh, I see.
You see it? Good job, Cindy. 2 points. Anybody else? Hey, look. Come on. I have 1, 2, 3 things being multiplied. One of them is a constant. So pull it out. Look at your pink sheet. Does the rule now apply? Nodding would be helpful. Yes. Questions? Please.
That's not lose constant value sign, right?
Yeah. That the absolute value sign is a little weird. It's necessary because, as we mentioned before, it's not possible to calculate the natural log of a negative number. So we have to force our result to say, can't never have a negative. Otherwise, we're writing something that doesn't make sense. So then you do one last substitution. You say this is equal to 3 natural log, and as we told the little girl, u is 2x squared plus 1, so.
It's not even that funny. It's so funny.
So I tell my grandchildren, u is 2x squared plus 1. And then you put a plus c. That's just the last little afterthought, you know. Oh, there's one more thing that will happen on the answer sheet. Raise your hand if you can answer this, please. Just raise your hand, don't say it out loud. Is there a value of x which will make 2x squared plus 1 negative? Raise your hand. Is it possible to choose raise your hand. Is it possible to choose a value of x which will make 2x squared plus 1 negative? Dawson?
No, because it's squared.
Right, and we're not using complex numbers, so any real number squared is positive, plus 1 is still positive. So the answer on the back won't have the absolute value because they're not necessary. Because 2x squared plus 1 is going to be positive. So the back will say that.
There's no reason. We just.
And we won't take the time right now, but if you use the green sheet rules and find the derivative of what you see here, you will find that to be the answer.
So like on the question, could you leave it with just the u because you have u equals to
Oh, hold on. Time to award a ticket. No, really. Look up. Hey, come on. Ticket-worthy question. Really is. As we've been practicing on FRQs, if all that's left is add, subtract, multiply, and divide, stop. If all that's left is, this one's a little trickier, but kind of general algebraic simplification, stop. You can't stop without resubstituting the u. That's part of calculus. Like we're learning a calculus technique, so we have to demonstrate that we understand the calculus technique. If you stop with the absolute value bars, though, you're okay, because that would be considered an algebraic simplification. So that's kind of just learning a little bit by experience, but yeah, you have to go to at least here. Good question. Anybody else? We want to talk more about what you see here. stop it, do another, oh, Justin, please.
Okay, so for the used, do we just go until we get it to match, and if it doesn't ever match?
That's kind of a shorthand way to say it. We'll do another example. You have to look a bit more in detail, but that's the general idea. And it is kind of magical in the sense that when you get to here, and you're like, oh, it appears like everything's going to work, just follow the steps and it'll work. Do it. Okay, stop this. Let's do another example.